All right, guys. Welcome to the Algebra Prep Questions Part 3. We're going to go over this problem together. This is the one you guys had from last week, so I want you to check and see how you did, okay? So it says that Elias tossed a ball into the air. The following table represents the ball's height with respect to time, where y represents the ball's height in feet and x represents the number of seconds after the ball was tossed. So part A just says to sketch a graph of the function. So we've got all the x's and all the y's. We can label this one as time and this as height. And then I'm just going to go through my x's. So 0, oops, sorry. It would help if you could see it. 0, 0.25, 0.5, 0.75, 1, 1.25. And that's all I have, so that's all I'm going to list. Our y's, we'll do 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we will just start plotting our points. So 0, 5 is going to be right here. 0.258 is going to be here. 0.59 will be here. 0.758 will be here. 1.5 will be here. And 1.250 will be here. And this is the graph of the ball when you throw it in the air. So that's part A. It says, what type of function would best model this situation? Explain your answer. Well, we know that these U-looking shapes are quadratic equations. So a quadratic function or equation. I'm going to say function because they use the word function. A quadratic function best represents the graph, because of the U shape. Because of the U shape. That's it. Part C says to write the equation that models the situation. So what we're gonna do is we're gonna look at 3 specific points from this table. Let's pick this point, and this point. I'm just trying to pick easy points. You can pick whatever ones you want, but these are the ones I'm gonna look at. So I'm gonna pick 0, 5, 0.59, and 1, 5. These are my points. I'm going to plug these points into the equation to figure out what our standard equation is going to look like. So when I plug in 0, this is, remember, y equals ax squared plus bx plus c. This is what it should look like. So I'm trying to solve for a, b, and c. And actually, I'm gonna flip it over on the other side so we've got some room to solve this. So let's look. We had the 0.05, 0.59, and what was the last one? 1.5. 1.5. So when I plug in, and this is our standard equation. When I plug in 0 for this, and 5, I'll get 5 is equal to, a will be 0. Oh, excuse me, x is 0, so a, this is 0, plus b, this is 0, plus c. So what you notice, a times 0, b times 0, those are going to be 0. So you get that 5 is equal to c. So we know that 5 is equal to c, and that makes sense too because this is our y-intercept, and you can see over here too that this is the y-intercept. So that's 1 down. Let's plug in another. Let's do 9 is equal to a 0.5 squared plus b 0.5 plus c. So let's simplify. 9 is going to be, this is going to be 0.25a plus 0.5b plus, we can go ahead and fill in c. We already know that c is 5, so let's go ahead and write it. So this is our second equation. Well, I guess technically, yeah, this is our second. And then let's plug in the last one to, let's come down here and say, actually, let's just make this a little bit nicer. Let's get all of our terms together. So this would be 4 is equal to 0.25a plus 0.5b. And then let's go ahead and get b by itself. So let's do minus 0.25a minus 0.25a. And we get 4 minus 0.25a is equal to 0.5b. And we can get b by itself by dividing by 0.5 on both sides. So we get 8 minus 0.5a is equal to b. All right, let's plug in the last one real quick. Last one is 1, 5. So we'll have 5 is equal to a 1 squared plus b times 1 plus our c, but we know it's 5, so I'll just use 5. So this turns into 5 is equal to a, because 1 squared is just 1, plus b plus 5. And I can get our numbers together. So we get 0 equals a plus b. And if you wanted to get b by itself, you'll have that negative a, if I subtract a on both sides, is going to be equal to b. And now we can solve for a using these two equations. I'm going to set them equal to each other. So since they're both equal to a, or both equal to b, I'm just going to set these two things equal. So I'll get negative a from here is equal to this part right here. So this would be 8 minus 0.5a. Now I can solve for a. Let's get the a terms together. So plus 0.5a. And we get 0.5a is equal to 8. And that should be negative. Divide by 0.5. Negative 0.5, excuse me. And we get that this is negative 16, which is equal to a. So I know a, I know c. Now I just need to figure out what b is. You can plug in b back into this if you'd like. So if I plug 16 into here, what we get is a negative 16 is equal to b. And then a negative times a negative is a positive, so we get 16 is equal to b. So I know that my b is 16. I know that my a is negative 16. I know that c is 5. I know it's a lot for one problem, but now you can finally write your standard form equation. So y is equal to negative 16x squared plus 16x plus 5. That's your equation. So let's come back over here and we'll write y is equal to negative 16x squared plus 16x plus 5. All right, and then last two. What is the appropriate range for the situation? Well, your range, just remember range is your y values. So if you come over here and look, we're going from 0 to 9. So 0 to 9 would be an appropriate range for this. So already we can eliminate the x's because we know we're dealing with range. So that leaves us with these two, and we know that our y values go from 0 to 9, so we're going to pick D. And the last one, it says Casey wrote the following one variable equation for the situation. What does Casey's equation represent? Well, remember that x represents time, so she's plugging in a time, and then what you get out, what do you get out? You get out the height. So we will get the height. You'll get the height at time 0.8. That's it. All right. If you guys have any questions, let me know. I'll see you in the next video.